These are the solutions to the Chapter 4 exam, Math 251. Okay, number 1, find the absolute max and min of f of x equals 1 plus 4x minus x squared on 0, 3. So for sure you're going to plug in 0, you're going to plug in 3, and you plug in any critical points too. So the derivative was 4 minus 2x, set it equal to 0, gives me x is 2. Plug in 0, I get 1 plus 0 minus 0, which is 1. F of 2, 1 plus 8 minus 4 is 5. F of 3, 1 plus 12 minus 9 is 4. So look at these. So the absolute max is at 2, 5. Absolute min is at 0, 1. Okay, number 2, function was f of x equals x cubed minus 3x squared. Give all of this stuff here. F prime is 3x squared minus 6x, which factors into 3x times x minus 2. F prime of x is 6x minus 6. Set f prime equal to 0. That gives me 0 and 2. 0, 0, and 2, negative 4. Sign chart, increasing, decreasing, increasing. So the function's increasing from negative infinity to 0, union 2 to infinity. F is decreasing between 0 and 2. So that makes 0, 2 a maximum, 2, negative 4 a minimum. Set f double prime equal to 0. 6x minus 6 equals 0. X is 1. Plug 1 back into the original function. 1 back in the original function, and you get negative 2. So 1 comma negative 2. Sign chart for y double prime. Here's 1, negative, positive, concave down, concave up. So the function f is concave down from negative infinity to 1, concave up from 1 to infinity, and an inflection point at 1, negative 2. Number 3, here's the solution graph. F prime of x less than 0 for all x. That means it's always decreasing. And see, f double prime is less than 0 for x less than 0. That means concave down. So decreasing, concave down. F double prime greater than 0 for x greater than 0. So concave up. And f double prime 0 equals 0, inflection point, and it touches the origin. So this is the graph. Number 4, limit x approaches 0. Plug in 0, you get 0 over 0. Use L'Hopital's rule. Derivative of the top is e to the x minus 1. Derivative of the bottom is 2x. Plug in still 0 over 0. Do it one more time. L'Hopital's rule. E to the x over 2. Plug in 0, 1/2. Number 5, x approaches 0 from the right of x to the x. Let y be x to the x. So ultimately, we're trying to find the limit as x approaches 0 from the right of y. Take the natural log of both sides. Ln y equals ln x, which is x ln x. So limit as x approaches 0 from the right of ln y is limit as x approaches 0 from the right of ln x divided by 1 over x. Multiplying by x is the same as dividing by 1 over x, but I'm writing it like this to do L'Hopital's rule. Now, when x approaches 0 from the right, ln x approaches negative infinity, 1 over x approaches infinity. So it's infinity over infinity type, even though it's negative infinity over infinity. Okay, so I can do L'Hopital's rule. This is x to the negative 1. So the derivative of the top is 1 over x. Derivative of the bottom is negative x to the negative 2. Swing the x to the negative 2. There's a negative there, if you can't see it. So negative 2 comes up, becomes a positive 2. X is in the bottom, there's a negative sign there. X squared over x is x. So limit as x approaches 0 from the right of negative x, and that's equal to 0. So I have, ignore the reds temporarily. The limit as x approaches 0 from the right of ln y is equal to 0. But I'm not really looking for that. I'm looking for the limit as x approaches 0 from the right of y. So I exponentiate. Put an e and ln cancel out. So the limit as x approaches 0 from the right of y is equal to 1. Okay, 6, similar theme. F of x is x over x plus 1. Horizontal asymptote, y equals 1. When x approaches infinity or negative infinity, you plug in a billion divided by a billion and 1, that's 1. Negative a billion over negative a billion plus 1, that's basically 1. And vertical asymptote, x equals negative 1. Okay, y prime, quotient root. Bottom times derivative of the top, 1. Minus the top times derivative of the bottom, 1. Over the denominator squared. 1 over x plus 1 squared, or x plus 1 to the negative 2. So double prime, negative 2 x plus 1 to the negative third, or negative 2 over x plus 1 cubed. F prime of x is 1 over x plus 1 squared. That's always greater than 0 for all x besides negative 1. So f is increasing from negative infinity to negative 1, union negative 1 to infinity. F is decreasing nowhere, therefore no max, no min. Double prime, I cannot set that equal to 0, okay? But I do have a sign chart still. I do have to pass an undefined value, which is negative 1. So put down the negative 1, pick something here and here. So I plug in negative 2, the denominator would become a negative. Negative divided by negative is positive. If I plug in 0 on this side, the denominator would be positive, so the whole fraction would be negative. So the function is concave up from negative infinity to negative 1, concave down from negative 1 to infinity. There's no inflection point. Even though there's a change in concavity, there's no point here, no ordered pair at negative 1, so there's no inflection point. Okay, number 7, y equals 2x minus 5. Which point is closest to the origin? So a crude sketch here. So from 0, 0 to x comma y, y is 2x minus 5. So using the distance formula, the distance squared, which I call f of x, is x squared plus y squared, 2x minus 5 squared. Try to minimize this. So f prime 2x plus 2 times 2x minus 5 to the first power times 2 by the chain root. 2 times 2 is 4. 2x plus 4 times 2x minus 5. 2x plus 8x is 10x minus 20. F double prime is 10. That's greater than 0, which tells me I have a minimum, which tells me if I have a concave up situation at a horizontal tangent, I have a minimum. That's what I'm looking for. Set f prime equal to 0. That's easy. X is 2. Plug back in to the original function. Y equals 2x minus 5. And I get y is negative 1. So the answer is 2 comma negative 1. Okay, 8. Square root of 6. X is square root of x. 6. Square both sides. X squared equals 6. Subtract 6. So my function is x squared minus 6. The derivative is 2x. So x1, my first guess is 2. You could pick 3. Okay, then using a shortcut, I hit answer minus answer squared minus 6 divided by 2 answer. If you don't have the answer button, no worries. You'll get it fairly quickly anyway. It comes out after just 2 tries. So 2.5, 2.45, 2.449, which essentially to 2 decimal places is 2.45. Okay. There was no question 9 or 10. Those are bogus questions. Everybody got a free 10 points on question 9 and question 10. So that was exam